Hi all, today we discuss the last two interpolation formulas, the Laplace formula. This is yp is equal to q times y naught. This contains two terms, two infinite terms. Okay, this contains infinite terms and this contains infinite terms. Even though it contains infinite terms, for the practical or application level, we will choose the first two terms of this bracket and first two terms of this bracket. That much terms are enough to get the approximate value of y. Okay, so we can neglect all those higher orders of differences. So please keep in mind that yp is equal to q y naught. This q is obtained from p, that is 1 minus p is equal to q, or other way p plus q is equal to 1, and p is obtained from this formula, x minus x naught divided by h. Okay, now we can discuss a example. This is the example. Use Everettes formula to obtain f of 1.15 given that f values are here. Okay, so we construct the table. Here we have x values. X values 1, 1.10, 1.20 and 1.30. We have only 4 points, and the corresponding function values are given, that is 1. And before that we write f value here, and that is 1.049. this is 1.096. this is 1.140. Okay, before that, before we calculating this table, we write p. What is p? By definition, p is equal to x minus x naught divided by h. Okay, first we have to set x naught. We need to find the value of 1.15. That is in between this 1.110 and 1.10 and 1.20. So 1.10 is to be selected as a x naught. So we write x naught is equal to 1.10 divided by h is equal to the length of the intervals. So that is 0.1. Okay, that is 0.1. Now this is our x value. So using this, this is our p value. Using this p, you can evaluate q by 1 minus p by this formula. So first of all, we evaluate this p. Our x naught is equal to this, so we write p is equal to 0 here, and here we have minus 1 and 1, and this is 2. So these are the p values. So let's complete the table. Delta f. Okay, delta y or delta y. What is delta y? The difference between these two. So that will be this minus this, so that is 0.49. So 0.049, and this will be 0.047. this will be 0.044. okay, now the next order, delta square y. Okay, we are using this delta square. This is our y. Delta square y is difference between these two, so that will be minus this one, minus 0.002, and we have difference between this minus 0.003, and we have delta q. We are not using this anyway. We write minus 0.001. okay, now you evaluate the value of this y at x equal to 1.15. So that corresponding p will be 1.15 minus 1.10 divided by 0.1, that is equal to 0.5. okay, so this is the p value. The corresponding q value will be 1 minus this, 1 minus 0.5, so that will be this 0.5 again, 0.5. so this q value and p value are the same. Okay, now you evaluate this formula. So the formula is, we will write the first two terms of this formula only, the first two terms. So that will be, I will write here yp, that is our y value, required y value. So the first term will be q times y naught, that is 0.5 times y naught. which is y naught. Y naught is this value 1.049 plus the second value will be 0.5 into q square, that is 0.25 minus 1, that is q square minus 1 square divided by 3 factorial, and delta square y minus 1, that is delta square y minus 1. So this is our delta y minus 1, and this is in fact this is our y minus 1, and this is y minus 1, this is y minus 2, sorry, this is y naught, and this is y1, and this is y2. So these are the values. So this will be a delta y minus 1, and this is going to be the delta square y minus 1. So we write it as this times minus 0.002. Okay, so these are the first two terms of the first bracket, and next we choose the first two terms of the next bracket. So that will be this plus we have p times y1. Okay, so we have 0.5 times y1. What is y1? Y1 is this number 1.096. okay, so the second term will be 0.5 times y1, p times p square minus 1 square, that is again 0.25 minus 1 divided by 3 factorial into delta square y naught. What is delta square y naught? This is delta y naught, and this is our delta square y naught. Okay, so we choose this one. Delta square y naught is minus 0.003. So we take only this much terms and simplify this. Okay, when you simplify this, you can get the value as 1.07282125. Please verify this number, and this is going to be f of 1.15. So this is the way we use this Laplace Everettes formula to evaluate f of 1.15. okay, next we will discuss the one more formula, that is what we called Newton's divide difference formula. So this is the last formula explained in this session 22.9. Now we have a formula, divide difference formula. So this is defined as let f of x naught, f of x1, etc., f of xn be the values of the function f of x corresponding to the arguments x naught, x1, x2, etc., xn. Then we define the first difference, divide difference, for the arguments x naught, x1. Okay, so the contrast to the previous case, as we pass arguments x naught and x1 to get the divide difference formula. This is defined as f of x1 minus f of x naught divided by x1 minus x naught. So this is denoted by the symbol f of x naught comma x1, or you can use the symbol delta x1 f of x naught. Okay, so this is another symbol for this divide difference, and or you can use x naught x1. Okay, so these are the notations to define to denote this f of x1 minus f of x naught divided by x1 minus x naught. Okay, so this is the difference. Using this divide difference, we will explain one more divide difference formula. So we write it as 22.9 G is Newton's divided, this is divided difference formula. This is f of x equal to f of x naught plus x minus x naught delta x1 f of x naught. So this is f of x1 minus f of x naught divided by x1 minus x naught. So that is the symbol here, and the next term will be x minus x naught into x minus x1 times delta square x1 x2. Okay, so this is of f of x x naught. Okay, so this is the second order divided difference formula. Okay, so that is obtained from this. Okay, so that is what is the second order divided difference formula. So this is defined as we will write the definition of this later. So times this times this plus etc plus, finally since we have n arguments, then the last term will be x minus x naught into x minus x1 into etc x minus xn minus 1 times delta n x1 etc xn f of x naught. Okay, so here we define this delta square of x1 x2, this f of x naught. Okay, so we know that what is this one, delta x1 f of x naught, that is f of x1 minus f of x naught divided by x1 minus x naught. So what is the square second order divided difference formula? Okay, so that is defined as f of x1 x2 minus f of x naught x1 divided by this x2 minus x naught. So this is the second order divided difference. This is also denoted by the symbol x1 x2 x naught x1 x2 or you can use f of x naught x1 x2. So this is nothing but f of x1 x2 minus f of x naught x1 divided by x2 minus x1. Similarly, you can define the third order delta cube x1 x2 x3 of f of x naught. Okay, so by definition this is equal to f of x1 x2 x3 minus f of x naught x1 x2. Okay, so to write the first term we use this one, and for the second term we start with this x naught x1 x2 divided by x3 minus x naught. So this is denoted by x naught x1 x2 x3, or you can write f of x naught x1 x2 x3. Okay, usually we use these symbols to denote these numbers. Okay, now we will discuss a problem or illustrative example for this. So that is our example. Using Newton's divided difference formula, evaluate f of 8. Evaluate f of 8 and f of 15. We have two questions, f of 8 and f of 15. Given that we have x values here, x equal to 4, 5, 7, 10, 11, 13. These values need not be in equal intervals. This is our f of x. The values 48, 100, 294, 900, 1210, 2028. So these are the values. So using these values we need to find out the value of f of 8. Okay, now we start the table, that is 4, 5, 7, 10, 11, 13. These are the values, and this is x values here, and this is f of x is here. This is f of x, that we have 48, 100, 294, 900, 1210 and 2028. So these are the values. Now we have to evaluate delta f of x. What is delta f of x? Delta f of x, here delta f of x is the divide difference, so that is denoted by delta x naught. This is our x naught, x0, x1, x2, x3, x4, x5. So this is delta x1 of f of x0. Okay, how will you find this? This is f of x1 minus f of x0. So that is 10 minus this is 100 minus 48 divided by, this is obtained as 100 minus 48 divided by 5 minus, so this is x1 is 5 here and x0 is 4, so you can write it as delta 5, this is, you write it as delta 5 4, so this is x0, this is x1, okay, that is here x1 minus x0, that is equal to, the value here is 52. Okay, so similarly we write, so this is in between these two, this is in between these two numbers, and we write the next delta 7 of f of 5 here, so that is obtained by 294 minus 100, 294 minus 100 divided by this 7 minus 5. Okay, so that will be 97. And next we have delta 10 of f of 7, that is 900 minus 294 divided by 10 minus 7, that is equal to 208. Okay, now we have delta 11 f of 10, so that is nothing but 1210 minus 900 divided by 11 minus 10, that is equal to 310. Finally we have delta 13 of f of 11, that is equal to, in the denominator we have 13 minus 11 obviously, so the numerator will be 2028 minus 1210, so this will be 409. Okay, now you evaluate delta square of this, okay, delta square of x, so this is divided difference, so that is obtained by taking the difference between these two. Okay, so that is denoted by delta 5 7. Okay, so this comes from these two numbers 5 and 7, f of 4, delta square 5 7 f of 4, and this is obtained by taking the difference between these two, 97 minus 52, so this is f of this 5 comma 7 and this is f of 4 comma 5 divided by the difference between these two numbers, 7 and 4. Okay, so that is the difference between these two, that is 7 minus 4, that is equal to 15. Similarly you can evaluate delta square of this 7 10 f of 5, so that will be 292 minus 202 minus here, sorry, 208 minus, so this is in fact 202 because this difference is always 202 minus 202 minus we have 97 divided by 10 minus 5, this minus this number, 10 minus 5, that is equal to 21. Okay, now you evaluate the third case, that is 10 11, and this is f of 7, this will be 310 minus 202 divided by 11 minus 7, that is equal to 27. As similarly the final one will be delta 11 13 f of 10, that is 409 minus 310 divided by 13 minus 10. Okay, so that is nothing but 33. Now you evaluate the final order divided difference, that is delta cube of f of x. So this is denoted by the symbol delta cube of three things, that is 5 7 10 of f of 4. Okay, so this is the denominator, we have difference between these two, 10 and 4, 10 minus 4, and the numerator we have these two differences, that is 21 minus 15, which is equal to 1. Okay, similarly you evaluate this one, that is delta cube of 7 10 11 of f of 5, so that will be the difference between 27 and 21, 27 minus 21 divided by 11 minus 5. Okay, so that will be 1 again, and finally we have this one, delta cube of this 10 11 13 f of 7, that will be difference between these two, 33 minus 27 divided by 13 minus this 7, okay, which is also equal to 1. So these are the table values. So using this table value we evaluate this formula. Formula is given here, f of x equal to f of x naught plus this x minus x naught into this plus etc. Okay, so finally we write the formula, that is why f of x equal to f of x is we need to find out the value of f at x equal to 8. So we evaluate f of, first we write f of x, that will be f of 4, this is x naught plus x minus x naught, that is x minus 4 into delta 5 of f of 4 plus x minus 4, this is x minus x naught and x minus x1, that is x1 is 5, so we have 5 here into delta square 5 7 f of 4 plus x minus 4 into x minus 5 into x minus 7 times delta cube 7 delta cube into 5 7 10 of f of 4, and the fourth term will be this delta raised to x minus 4 into x minus 5 into x minus 7 into finally we have x minus, so we have only 3 third order, so we need to worry about these things. Okay, so just remove that. So which is equal to, what is f of 4? F of 4 from this table we have f of 4 is equal to 48, so we have 48 here, okay, plus x minus 4, so we need to evaluate f of 8 first, that is 48 plus 8 minus 4 times this value delta 5 f of 4. What is delta 5 f of 4? That is 52, so we choose this one. First we choose this 48, then we choose 52, so this is into 52 plus 8 minus 4 into 8 minus 5 times that number, which is 15, this is 15 plus we have 8 minus 4 into 8 minus 5 into 8 minus 7 into this value, that is 1, so that is 1. Okay, so we will have this is equal to 448, so this is the value of f of 8. In similar fashion you can evaluate f of 15. The only difference is we start with this 48 and we have x minus 4 here, that is 15 minus 4. Okay, here we have the same thing, and the next time we have 15 minus 4 into 15 minus 5, etc. Okay, so you will get the value as f of 15 as 3150. Okay, so these are the two values. So with this example we can conclude section 22.9. Okay, in the next class we will discuss section 22.10, that is numerical differentiation. Okay, so in the next class we will discuss that. Thank you.